All right, how are you doing today? Hope you are doing great. Today we'll be learning a new part of a topic, and it is called changing the direction of light. This is summarize the end of the topic, and we're going to proceed to our practical. All right, we'll be talking about light. We talked about light. We said light travel in a straight line, and then we also learned that light interacts with matter in different ways. We said it is transparent, translucent, opaque. We also learned that when light reflects on a very smooth surfaces, it forms image of an object, just like the mirror. All right, today we are going to be seeing how can we bend the direction of light. Okay, light travel in straight lines, and the ray or beam of light do not bend. A beam of light is a ray of light that is actually traveling. So we discover that we cannot bend it. So how is it possible to see light that are behind us or above us? What can we do to see things that are around a corner or over a wall? What they're asking is this. Remember in our last topic we said when the light hits the plane surface or the object, it reflects to your eyes and then you are able to see the object. When the light shines on an object, it burns to your eye and then you are able to see the object. What about how can you see an object that is above your head or that is at the back of your head? What can you do to light to be able to see it? You can actually see object behind your head or above your head with the help of what we call a mirror. We can use mirror to change the direction of beam of light. When the light falls on the surface of a mirror, it is reflected off the mirror and changes direction. The light reflects off the mirror at a certain angle. So we can do this using the help of a mirror. Why? Because mirror does not absorb any light at all. It reflects all the light in a different direction, and so we are able to use a mirror. How does a mirror works? Look at this guy playing the snooker. This young man using his left hand to play snooker. Now, what is he trying to do? He's going to use that stick to pot that ball, and then the ball is going to move at this straight line I'm seeing at this angle, and then it will hit this wall and it will bounce back and hit this ball. Okay, are you seeing what is being formed there? When it hits this ball will move in this direction to this pocket. This is where he wants to put the ball. All right, now this scenario you're seeing is the same thing as what happens in a mirror. When the light shines from this direction, it hits the mirror at this surface and then it reflects towards this direction. By this we have bent the light ray or the light beam, because the light is supposed to go through this direction, which is a straight line, but because of the mirror that is here, okay, it has been able to bend the light towards this direction, meaning that assuming your eyes were here, you will be able to see this ball because of the light bending. All right, let's take another look at this. Look at this intelligent girl. She's using a periscope to look at some children playing on the other side of the high wall. What do you think is inside the periscope? If you take a close look at the periscope, all right, you will discover two lines are drawn. Let me show you. Look at this line here. There's a straight line here. What do you think is that? And there's another straight line here. Those are mirrors. Alright? What's actually happening is that the light from this source playing, these guests that are playing here, we enter this place. You can see the arrow there, and then it will be reflected on this mirror, and this mirror will bend. Remember, it's coming from this direction. As it's coming from this direction, it will bend to this direction, and then the girl will be able to see the image form on this second mirror here to her eyes. That is how it works. Alright, I know you want to know what is a periscope. So a periscope is an instrument for observation over, around, or through an object, obstacles or conditions that prevent direct line of sight observation from an observer's current position. What this means is that the periscope is an instrument that enables you to see where your eyes cannot see because of obstacle, just as the fence is an obstacle to this girl. So the periscope allows you to see where your eyes cannot see. For example, your eyes cannot see the back of your head. If you want to see the back of your head, you have to apply a device just like the periscope. If you want to see above your head, you apply the periscope. That's why in the military system of war during World War One, the periscope was largely used to see enemies over a wall. Because if the soldier decides to raise his head to look over the wall, what can happen to that soldier? You already know, right? So he uses a periscope to look over a wall to see his enemy. We also use the periscope in the submarine. Submarine are those ships that move underwater. Alright? You also use it in submarine navigation. Elsewhere, it enables an observer to see his surrounding while remaining under cover, behind armor, or submerged. Alright? So we use the periscope in different fields, but you already know what the periscope is now, and you're going to be making one for me. Alright? Now, look at another simple application. How can you look at the back of your head? Normally, you can only see the front of your head. For you to see the back of your head, you need to do a simple practical, which I would love you to do with the help of your parents or your brother or your sister. Alright, let me help you demonstrate this so that you understand what is actually happening. Now, what do you think is happening in this mirror? This young man that is looking very gentle, okay, he's looking very gentle. He is able to see the back of his head because of the bending of the light. Light comes from this source and hits the mirror, and then reflects back to this boy's eyes, and the boy is able to see himself, his face. Alright, now this same light from this source enters this mirror and moves, is bent, okay, not to his eye this time, but to this mirror behind, and then this mirror bends the ray back to the second mirror, and then it bends the ray back to the boy's eyes, and is able to see the back of his head. That is how it works. Alright, let me take it again. Light from this place hits this mirror, and it bends or is reflected back to this mirror, and then this mirror reflected back to this mirror, and then it reflects back to the boy's eyes, and the boy is able to see the back of his what? Head. That is how the periscope works with that young girl you just saw. Alright, this is a very good application of what I'm saying. This is this light source from this torch, and it's coming to this mirror, and then she bends the mirror, the light in the mirror, towards this direction, and you can see the light reflecting on his body. Okay, now if you draw a straight line here, and then you have this angle like this. If you measure this angle, which is angle of incidence, and let's say it gives you 20 degrees, and then you measure this other angle, which is angle of reflection, it will give you 20 degrees as well. Okay, this is what we call the reflection, or this is how we can actually bend light to see an object. Now, if peradventure I ask you to demonstrate this for me, that is what you should do. After drawing your diagram, you draw a normal. We call this a normal. Draw a straight line. That straight line will be between the light source and the object the light is shining on. Okay, so you draw it between the light source and the object the light is shining on, and then you take your protractor, you measure this angle and measure this angle. You discover that they are almost equal, or they should be equal. When they are almost equal, your answer is actually correct. But when they are equal, your answer is very, very accurate. All right, this is what you will get. Okay, this is your light source, this is your light source, this is the mirror, and this is your what? The object, or the reflected ray. So this is the incident ray, this is the reflected ray, and then this is your normal. Okay, and this angle is angle of reflection, and this angle is angle of what? Incidence. That brings us to the end of this class, and you must know that a beam of light can change direction when it's reflected from some surfaces, such as what? Your mirror. In our next class, we are going to be carrying out a practical, so get ready, get your mirrors. We are going to be carrying out either of two practicals, which I will show to you. Until then, stay safe and do your assignment. Bye.